I'm Pat Rife. I'm a professor in physics and astronomy at Rice University, and I'm a veteran of 15 times on the center line, 13 totalities, and 2 angulars, and then another couple partials, and but they don't count. So my first one was in 1979 in Canada. And I remember we all said at the time, the next one to cross the United States is not till 2017. That sounds like forever. But here it is. So it's really exciting that so many of you and so many people around the country will be able to see the eclipse. So I got a little money from NASA to create some clips, educational clips. And I wanted to show you my clips and also share some of my experience and some of my tips and tricks from things that I have done wrong over the years, so you don't have to do them too. Okay, so let me pull up the chat window, so if anybody has a question, they can type it in the chat window. You get to the chat window at the bottom of your screen, or you can just interrupt me. Interrupting me is fine. If you want to just put it in the chat window, I'll try to keep an eye on it. Okay, so I am now going to share screen. Stop. And we'll go to the point. Okay, so I call this kind of Eclipse 101. Where to go and how to observe it safely. And I have I'll send you the link. I have posted this PowerPoint in 3 different ways. One is a PDF with links to the movies, or as a full PowerPoint with the movies in it. It's like 90 megabytes, and as a one with the movies and one without the movies. Sorry, I got distracted by a question. The brand of solar UV beads from Walmart, I think you just go to walmart.com and punch in UV beads. I tell you what, when we get, remind me, and I'll pull up Walmart and I'll show you where I found them. But I took them out in the sunlight, and they colored up really fast, which was nice. It's nice to have them color up fast. Okay, so back to the PowerPoint. So the question is who, what, where, why, how, and when. The typical what you want to know. So who will be able to see it? So the point is that everyone in the continental United States, unless they're completely overcast, will be able to see at least a partial solar eclipse on August 21st. Most of them will be able to see at least 50% or more. Houston will be 66%, and millions will be in the path of totality. It's going to go through several big cities. The only country that sees totality is the United States. And this map, which is from eclipse2017.nasa.gov, which is, by the way, a fabulous site. There's tons of downloadables, just all kinds of information, and feel free to get whatever you want from there. So this shows the path. It goes north of Bend and north of Eugene, but goes through Idaho Springs and Jackson Hole and Casper, and it goes near Lincoln and Omaha, Nebraska, near Kansas City and St. Louis and Carbondale and Columbia, Missouri, and Columbia, South Carolina, and Nashville, and a little bit of Georgia. So it's going to hit quite a few states on its way through. Okay. Now you'll notice the times starts at about 10:30 in the morning Pacific time and ends at 2:30 in the Atlantic, in the Eastern time zone. But that really only is about an hour and a half that it takes to cross the entire United States. So one of the things that's going to be happening in this event is a group called the Eclipse Mega Movie is going to be taking everybody's best photographs, and they want to be sure you timestamp them accurately, and they're going to put together a movie of all of everybody's best totality pictures so they can watch the sun change as a function of time across the country. And so they are giving out these glasses, which are called, the Eclipse Mega Movie. And I think their website is eclipsemega.movie. Okay. And for all of you who are going to have an event at your school or wherever, if you're going to have a public event or a public training, I will send you a pack of 50 of these. Okay. You got to tell me where your training's going to be. You've got to give them away free only. Okay. If it's not public or school, then you have to purchase them. You can't use these unless you're doing some event, okay? If you want ones that you can sell or use for your own family or whatnot, I've got some that I bought in bulk that I got at really good price, and so I'm passing the savings on to you. So the idea is, after this training, send me an email, tell me what your event's going to be, and all you have to do is pay for shipping. Okay, and if you in the zone of totality, if you're going in the zone of totality, you can get up to 100. If you're not going to be in the zone of totality, it's 50. Okay, and if you want more, then you can buy these, and if you buy these, you won't have to pay for shipping for those. Okay, so we'll talk more about that later. But and I'll give you 2 pair free if you'll send me a stamped, self-addressed envelope. Okay. All right, so that's that. So here's the path of totality, and it starts at sunrise here and in the ocean and goes across the United States and ends at sunset in the ocean over here, okay? So no other country is in totality besides the United States for this one. But you do notice the fractions, okay? So 90% is when I start noticing that things are going to get dark. 70 or 80%, you can see it in the, using your viewers, but it's not real noticeable that it's getting dark. But here is around 50% is for South Texas and for southern, the very northern Maine. But most of the rest of the country sees a pretty good eclipse of 60% or more. So what is a solar eclipse versus a lunar eclipse? And most of you probably already know this, but a solar eclipse is the moon casting its shadow on the Earth, whereas a lunar eclipse is the Earth casting its shadow on the moon. Totality means that the entire sun will be covered by the moon, allowing us to see the sun's corona. And only during totality will you be able to take off your filters and see the corona in its totality. This is a little sketch of the eclipse, and It's on my website, space.rice.edu/eclipse. It's in the Eclipse FAQ folder. Okay, so here's the sun, here's the moon, and the moon's apparent angular size, which is its length divided by its distance, is almost exactly the same as the sun, which is its diameter divided by its distance. And of course, this is not to scale. If you are in the umbra, then the moon will be able to completely cover the sun based on where you are, and you'll have a total eclipse. But if you are in the penumbra, the sun is only covering part of the moon is only covering part of the sun, and so you only get a partial eclipse. So penumbra is partial. Now, I have given you all a link to a worksheet, and if you want to get your professional development hours from me, you've got to fill out this worksheet. That's not that hard. It's trivial mathematics, 2 pages, 2 sides, okay. And basically what it is, it just has you calculate the angular size of the average moon and the angular size of the average sun, and see how they are, okay. And it turns out that the average moon is slightly too small to cover the average sun. So what does that mean? The reason that we have total eclipses is that the sun's apparent size and the moon's apparent size change during the year or the month, respectively, because of the orbits are ellipses. And the ellipses is described again on this page of the second page of the handout, that the Earth's orbit is not quite circular. It's off by about 1.7%. So the sun appears to be 1.7% larger or 1.7% smaller in diameter based on the ellipticity of the Earth's orbit. Similarly, the moon in its orbit around the Earth is about 5.5% eccentricity, and so the moon size varies plus or minus 5.5%. So even though on average the moon doesn't cover the sun, because of the ellipticity of both orbits, it still does. And so when you send me in your sheet, you don't get grading. Yeah, I'll send you again the link to the homework. And all the links are there. In fact, I can show you that right now. Let me show you the links. Hang on. I gotta move this out of the way. But I will send you, let's go to my website. Oh, here's the Walmart. So this is the Walmart one that I bought just now. $8.99 for a pack of 500, which is 2 of these little bags. And I ordered 2,000, so it was $33, which is not much at all. Okay, and then let me, if you go to space.rice.edu/eclipse/PDF, okay, that's kind of a hidden directory, so you are, you guys are the good guys, so you get to find it. space.rice.edu/eclipse/PDF. So here's the Eclipse math. That's the homework. Here's Eclipse 101 PDF. That's the PDF of this the PDF of this presentation. Now, the movie links may or may not work directly from the PDF. I tried to set it up, but I don't know whether they did. And then here's the Eclipse PowerPoint with just the links to the movies, and then here's the PowerPoint with the links and the movies. Okay? And then here's the safety sheet, which is also useful, and my Umbra file journal, which is kind of fun. This is an Eclipse reading chart, which is kind of cool, because you print that out at arm's length, and you can see through the event what's the smallest font that you can read. And so it gives them something to do while waiting for the eclipse, for totality, is to see how, use this as a way to judge the light level going down, is what's the smallest font you can read. Okay, so that's that. All right, back to so a lunar eclipse is when the moon is in the Earth shadow, but the Earth is a lot bigger than the moon, so lunar eclipses are a lot more common. So this is the first of my animations. Again, you can download all of these for free from this website. And again, that one you can see on the top level of my Eclipse website. And so I'm going to play it for you, so I save my voice.
When the new moon passes exactly in front of the sun, its shadow crosses the Earth. The deepest part of the shadow is called the umbra. People in the umbra see a total solar eclipse. It takes about an hour for the shadow to cross the Earth. 2 weeks later, the full moon can cross into Earth's umbra. Since the Earth is 4 times the diameter of the moon, the umbra is also 4 times larger, or 16 times the area. So, lunar eclipses are more common than solar eclipses. Everyone on the night side of Earth can see a total lunar eclipse, but only people in the narrow strip of totality can see a total solar eclipse. So, not only are lunar eclipses more common, more people can observe each one.
Okay. These animations were created for planetariums, so they're actually full dome, and they really are nice in a planetarium. So if you know of a planetarium that would like to have them, again, they're free for planetariums. They just need to contact me, and I'll give them the download instructions. Okay, so the eclipse has phases. First contact is the beginning of partial. Second contact is start of totality. Third contact is end of totality. And fourth contact is the last of the partial phase. So here is a video that shows how this will look from Earth.
First contact is when the disk of the moon first starts to cover the sun. During the partial phases, you must use solar filters or projection techniques to safely observe the sun. It takes about an hour for the moon to completely cover the sun. The last bit of the sun is the diamond ring. Second contact, totality. Third contact, put back on your filters. The last hour, the moon gracefully exits, uncovering the sun. As the last bit of the moon leaves the sun, it is fourth contact and the end of the eclipse.
Okay.
First contact.
Sorry. Oh. So what will you see when it turns total? Okay. This is the corona, And as I said, only during totality will you be able to see the corona, only if you're in the zone of totality and only during totality. But once this moon covers up the sun, you'll be able to see these prominences along the edges of the sun. You'll be able to see the corona. Some of it is loops. These are looped magnetic fields, and some of them are streamers. So some of the magnetic fields close on the surface of the sun, and some of them extend out into space. The ones that extend out into space, the solar wind is a lot faster than the ones that are from closed loops. And that's what's some of the things that I study is in the area of space weather. Okay. So right before totality begins, the last bit of the sun that's covered up, that is not covered up yet, that's called the diamond ring. And this picture right here is a photo of the diamond ring. Now, the diamond ring, you are not, it's not a good idea to see the diamond ring with your naked eye because it is still the sun, okay? But if you are taking photographs with a camera that does not have a optical viewfinder, or if you are using a camcorder that doesn't have an optical viewfinder, that only uses an LCD panel, both of those you can take off your filters just a tiny bit early so you can make a picture of the diamond ring. However, I recommend you don't do it early. I recommend that you do it late, and I'll tell you why. This one is going to be really spectacular in the moon shadows. So I really don't want you to take pictures coming into this. I want you to experience it coming in, and I'll tell you a little bit why. But let me just now show you this animation of what it would look like from a
As the
camera.
moon covers the last bit of the sun, the sky around you gets dark. It's still not safe to remove your solar filters, though. The last piece of the sun makes a diamond ring. Bailey's beads appear, small bits of the sun peeking through valleys on the edge of the moon. Now it's safe.
Okay, so once you've had the diamond ring and Bailey's beads, then you can take off your filters. And once it's total, you can use your naked eye. You can use your naked eye. You can use binoculars. You can use telescopes without needing any filters whatsoever, but only during the time of totality. Now, this is what the moon shadow would look like on the Earth as seen. This one was from an Earth orbiting spacecraft. You'll notice it's not a really sharp spot. It's very fuzzy. Okay, so this is a real photo, and again, here is our animation of what it would look like.
This shows how the moon shadow might appear from a spacecraft in Earth orbit. This sequence is based on actual previous space-based photography. The moon shadow isn't just a sharp dark spot, but has shading as the penumbra darkens to the umbra at the center. Since the spacecraft is in the penumbra, the sun is only partially covered by the moon.
Okay. So that spacecraft is seeing a partial eclipse up here. Now, lunar eclipses, as I mentioned, were a lot more common, and recently we had four total lunar eclipses in a row, which was really spectacular. I hope everybody saw at least one of them. They're a lot slower, and but the moon gets really, really red during a total lunar eclipse. but it can be brighter on one edge than the other if it's closer to the edge of the umbra. Now, two of them in Houston were very special. They were selenelians, and I didn't know what that word was until somebody pointed it out to me. A selenelian is a case where the total lunar eclipse happens at either dawn or dusk. In this case, it was dusk, so we were looking in the east at the moon, which is now coming out of totality as the sun was setting in the west. So you can see the red and the clouds. And what was really cool is you really get the geometry, because you can look to the west and you saw the setting sun, and it's red because the blue light is scattered by the atmosphere, okay? So you're seeing the red light from the sun passing over our head and shining on that moon and making the moon red. So the red light on the moon was passing over our heads, which was just really amazing, because we were on the top of a building, and because there's some refraction, you can actually see both at the same time. Here the moon was just coming out of totality. So here is an animation of a lunar eclipse as seen from Earth.
A lunar eclipse as seen from Earth is leisurely, taking 3 hours or more. When the moon enters the umbra, a dark whiteout appears and grows, the partial phase. When the moon is entirely inside the umbra, totality begins and can last for an hour or more. The moon appears red because the only light reaching it is refracted through Earth's atmosphere. One side might be brighter than the other because it is closer to the edge of the umbra. When part of the moon emerges from the umbra, totality is over. When all of the moon emerges, it's the end of the eclipse.
Okay, so now that was a lunar eclipse as seen from Earth. But now let's think about what it would be if you were actually on the moon during a lunar eclipse. What would it be for you? It would be a solar eclipse for them, because they would be passing into Earth's umbra.
In a lunar eclipse, the moon travels through the Earth's shadow. If you were on the moon, it would be a total solar eclipse for you. But the Earth appears 4 times as big as the sun. The land around you gets dark. When you are completely in Earth's shadow, the land around you is red. The only light that reaches you is red light bent by Earth's atmosphere.
And you notice the atmosphere of the Earth, it looks red, okay? So you're seeing the light from the sun, only the red light gets transmitted, the blue light gets scattered. Okay, so if the moon is too far away to cover the sun, we get an annular eclipse. So you'd have to be in Earth orbit in order to see a totality. The shadow cone doesn't quite reach the surface of the Earth. And so what you see, even though you're exactly on the line, you see a ring of light around of sunlight around the moon. The moon is just a little bit too small, and there's a little bit of the sun in an annulus, so that's why it's called an annular eclipse. So this was with or without filters from Sandia Peak. Okay, so where do I need to go to see it best? And, you know, if you possibly can, go to totality, because it really is spectacular. Try to be not more than 1 or 2 hours from the center line, so that, you know, if you can't get a hotel in totality, you know, stay nearby and drive in that morning. But drive early. I mean, start hours and hours early, because there's going to be a ton of traffic, and the good parking places are all going to go soon. So, be careful and plan ahead, because you can't assume that city parks will still have uh, uh, parking spaces available. There's a really nice interactive map, and you can get to it from my website. And it's a Google map, and will show you the locations where and the timings of all of these first, second, third, and fourth contact in the various places. You can get to it from my website, so let me show that to you here. So if I just go to base.rice.edu/eclipse, okay, so there's the solar eclipse reading chart and the solar eclipse frequently asked questions, and here are some more useful resources. But one of the most fun is this interactive Google map. So remember, this is in universal time, not in local time. So you have to add or subtract. So, for example, here in Houston, it will max at 1818. Okay, well, in Central, you subtract 5 hours, so that would be 1318. So it would be almost exactly dead solar noon in Houston, and the altitude of the sun will be 72 degrees, which is a neck killer. Because it's hard to hold a binocular straight over your head that easily. So, get a lounge chair. On the other hand, let's go back to Wyoming, near where I am, and the maximum eclipse will be at an altitude of only 52 degrees, which is reasonably comfortable. Okay, so something at 50 to up to 60 degrees, you can put binoculars on a tripod and be comfortable. But this is zoomable. You can go all the way in, and like any good map, and find out exactly where you are. So there's been slightly out of the zone of totality in Eugene, but Salem's in the zone of totalities. So it's a really handy thing. Now there's also a NASA version that takes into account the mountains on the edge of the moon, and actually gets this edge a little bit more accurate. But as far as I'm concerned, you don't want to be at the edge anyway. Try to stay in the middle half of this, and you'll have the longest. So here's Kentucky. That's where it's going to be the longest. Okay, so take these numbers and subtract 4 hours if it's Eastern time zone. So that would be 1841, which is 1440, which is 240. Okay, so it's ending around 2:50 in the afternoon, whereas it starts here, and that's 1716. So it's just about an hour and a half to go all the way across from 1716 to 1841 in universal time. But in local time, it's like 10:30 in the morning to 2:30 in the afternoon. So bear in mind the difference because of daylight savings time and the time zones. Okay, does that make sense? I really like that map. It helped me find where I was going, where I'm staying. And what's cool about where I'm staying, there's a road that goes straight to totality. So if I have to move because of weather, I can move a little bit and still stay in totality. But the traffic's going to be so I don't think I'm going to move. I have been several times when people did quick moves at the end, and sometimes it just made it worse. So prayer is good. All right, back to the PowerPoint. Yeah, I've been the eclipse leader on a number of tours, and when we were in Peru, the guy was kind of embarrassed. He says, "I have a group of New Agers that want to pray during the eclipse. Do you mind having them in your group?" And I said, "Oh, heavens no, I don't mind people praying for when it's an eclipse." And we had a good time. Okay, so that's the map. Okay, why do I need to go to totality? And this is where I really want to encourage you, because everybody can show you pretty pictures, but there really, really isn't anything like being there. Um, the photographs just really don't do it justice. Um, it's not just your eyes, it's your skin. The temperature falls, the wind picks up, it's your ears, you hear the birds roosting. The there's just an eeriness to the sky as the shadows get really sharp. The sun is only a half a degree across, but that's enough to make your shadow fuzzy. But once that sun starts necking down to a little sliver, your shadows get really, really sharp. The birds roost. The clouds become more transparent, and this is something I want to tell you, that if you think, oh, it's hopeless, I see clouds today, we're screwed. Um, don't give up, because why are clouds white? Because they're scattering sunlight. And when the sun gets small, there's less scattering. There's less scattered light, and so they become more transparent. So this one, we were in Indonesia, it was fairly cloudy, and yet we still were able to see uh, the uh, the the sun. I see a question over here. Oh, Naval Observatory link. Thank you. Thank you. Um, these are some of my favorite pictures of the diamond ring, because it is absolutely spectacular. And you can get these wonderful halos around the sun. Now, why do we need to see an eclipse? I mean, we have spacecraft that monitor the sun all the time and take essentially eclipse shots all the time. Okay, we use certain wavelengths of light we can image. Ultraviolet that doesn't normally get through our atmosphere. That's imaged by the SOHO and SDO spacecraft. And then we have coronal monitors on SOHO, where they took an occulting disk and blotted out the bright part of the sun so that you could see the inner corona, and these called coronal mass ejections that blast big parts of the corona out. And then they have another outer corona monitor, which is an even bigger disk, so that you can see the outer part of the corona. See this bar here, that's where the occulting disk is. It's like a lollipop that they're sticking in front of the sun, so they can take a picture of the corona and monitor it. But they can't get very close to the sun, because this, as I pointed out, the sun's relative size changes, and so you don't want to be you want to not be blinded by the bright inner corona when you want to see the dimmer outer corona. So with your eyes, you can see it all at once. It really is amazing how good your eyes are at allowing you to see the inner prominences and the outer corona at the same time. A camera just can't do it. So here is one of these coronal mass ejections seen by spacecraft. Well, here was one sketched in the 1860 eclipse, and he had no idea what he was seeing, but he sketched it, and it's amazing that that's exactly what it really looks like. The corona shape varies from year to year. When you have the sun near solar maximum, it's sort of like what a third grader would draw. The rays of the sun go out in all directions. But when we have a solar minimum sun, which is what we have now, the corona will be elongated along the sun's equator. So it'll be longer along the equator and less at top to bottom, okay? Now, do you see this corona going way out? No, because this is a photograph taken with a single exposure. If you do a really short exposure, you can see the prominences. If you do a middle exposure, you get the inner corona. You have to do a long exposure to get the outer corona, and when you do that, you way overexpose the prominences. So your eyes with the binoculars can see it much better than any photograph. And that's one reason why I say it's really critical to not spend your entire totality behind a lens. Enjoy it with your eyes. There will be other people that take better pictures than you, I guarantee. Now, I like to take fisheyes because I work a lot with planetariums. So I take a fisheye picture that shows the entire sky at once, okay? And so here is the eclipse, and it's blown up here. I called this Dragon Eats Sun because we were really lucky. We had to jump in a hang on, my friend is calling me. I need to put my phone on do not disturb. Hang on. Okay. We had to jump in a bus and move a couple of miles because we were afraid that the sun was going to be covered up by this cloud, and we just made it. It was very exciting. But you see the sunset around you, okay? Because people in these areas are not in totality, okay? And you'll notice there's no sunset right underneath the eclipse because that's the shadow of the moon. You're actually looking through the moon's shadow. Here's another one that was in the early morning from a cruise ship in 2012. You can see the brighter planets and the brighter stars. So it's not super duper dark, but you can still see that that looks like sunset all the way around you, except right under the eclipse where you're in the shadow of the moon. Now, if you are close to noon, which most of us are reasonably close to noon, it's going to be close to this picture of mine, which was taken in Libya in 2006. When it's close to noon and the sun is relatively close to the zenith, okay, then you get the sunset all the way around you because you're symmetrically in the center of the moon's shadow. But what is more important, when this sun is more overhead, right before totality, look to the northwest. Forget the cameras. At this point, you can even forget the eclipse glasses. You can look straight to the northwest, not at the sun. Look straight to the northwest. No eclipse glasses. Within the last few seconds before totality, and you will see that moon shadow approaching you at 1,000 miles an hour. So it goes from looking like a tornado on the horizon. It grows immensely fast and just washes over you. And when you do it, almost knocks you back. It is so spectacular. And when that moon shadow washes over you, you look up and it's total because you are now in the shadow. And I mean, that still gives me goosebumps remembering how spectacular that was. And that is one of the coolest things about being in totality when it's one near noon. is the moon shadow. You don't see that as well when it's near sun set or sunrise. You really only see it best when it's near noon. But again, you see, I got the picture of the sunset. I overexposed the eclipse. So there's always, there's always trade-offs when you're taking pictures. This was the one in Indonesia this last year, and the sun was kind of in and out of the clouds, but we still got a good view. We even saw Venus through a crack in the clouds. I have a video of this. If we have time, I'll show it to you. So, how do I observe it safely? Well, absolutely key to protect your eyes, okay? Even when the sun gets to be a little tiny sliver or even a diamond ring, each pixel of the sun is still maximum brightness, okay? So your eyes think, oh, well, it's getting dark, so it must be safe. It's your eyes fool you into thinking, well, I must be able to look at the sun since it's getting dark. But what will happen is that little image, that little sliver of the sun will be burned into your retina, and that could be permanent. So it's really, really critical that you protect your eyes. You have to have special filters for your eyes or for your binoculars or for your cameras. Only during totality is it safe to view with your naked eyes or unshielded binoculars. Okay, so I'll show you some of my favorite ways to see it. Everybody says pinhole cameras. I frankly am not that happy with pinhole cameras, but I will show you something cool. All right, so here we are on that. This was that 2012 one, getting ready for totality, and you see everybody's filters ready. He's got a solar filter on his camera, and different people are using different things. One of the things you notice, a lot of people have whistles to tell each other that it's total. They'll sometimes have headlamps, and headlamps are very important too, because it does get dark. So here's the safety write-up. It's on the NASA site. It's also on my site, so you can download that and print it out and give it to all of your people. So here's the pinhole projection. Now I did this in 15 minutes. Okay, so I found a long box, and I punched a hole in it, and it was kind of ragged edge. So I put a piece of paper over it and punched a smaller hole. That gave it a little cleaner hole, and sure enough, I got an image of the sun, and it's little bitty and dim. Well, if you try to make the hole bigger, all it does is make it brighter, but it makes it fuzzy. It's not in focus. So I tried something different, and I was really surprised that it worked. I made a much bigger hole, and I put a little pair of readers on there. And sure enough, I got lucky that the focal length of the readers was about the size of the box. And I got a much brighter image, and it was in focus. So you can have this box there with a piece of paper at the bottom. People can stick their heads in. You notice I punched it sort of toward one end, so people could stick their head in and see it, and you can watch the progression of the eclipse. But it's small, and it's not that exciting, really. But it's safe. Now, one fun thing you can do with pinholes, and I really recommend doing this, have some of the kids in your group, draw a picture or the name, the location, or the date, and punch holes in a piece of heavy cardboard, okay? And then when you're near totality, better when you're after totality, because then all the hoorah is over. Then pick up this board and take a picture of its shadow. So each one of these pinholes makes a little tiny eclipse. And that's what's really fun. You can take a straw hat. You can even take your fingers like that and make a bunch of little tiny eclipses. If you look under a tree that has lots of leaves, you'll see a lot of little tiny eclipses because they'll make basically little pinholes. Okay, so this is my favorite pinhole projection. Just punch something into a cardboard and then look at its shadow, because then you get the nice shadow around it. Eclipse shades, they're cheap, they're easy, but they don't have any magnification. So that sun is a half a degree across. A half a degree across is my little fingernail at arm's length. You know, that's kind of small, okay? So you can monitor safely the progress of the eclipse. If there's some big sunspots, naked eye sunspots, then you'll be able to see them in this, but they don't magnify the sun. So they're good and they're safe, but they don't magnify. Now, what I really prefer is to take a pair of binoculars and put solar filters on them, okay? Now, binoculars basics, every pair of binoculars has a set of numbers on it, okay? This one has a set of numbers that says 8 by 42. That means it's 8 magnification and it's 42 millimeters across, okay? So these are good, decent binoculars. They're high quality, good enough for observing. 8 magnification is better than nothing, okay? My preference is more like 12 or a little bit more, okay? So, but this would work, okay? Any size between about 35 and 50 would be fine. I also have some 80s, 11 by 80s, but they're huge and very heavy and really not necessary because the sun's good and bright. Now, this is the favorite ones that I've recently bought, and these are zooms. So if you look on its label, it says 10-22 times 50. So it's a 50 millimeter aperture, and it zooms between 10 magnification and 22 magnification. These are about $150. They're Nikons, and I really, really like them, okay? What's good about the zoom is you zoom out to find it, and then you zoom in to make it larger, okay? Now, the problem again is holding it steady. So finding the sun when you've got filters on your binoculars is not easy. In fact, finding a bird with binoculars is not always easy. So what I have learned, the trick that I have learned over time is, hang on, let's see if I can. Let me stop sharing for just a second. So what I have found is that if I'm looking at a bird, okay, and I just put up my binoculars, I can't find it, okay? So what I do is I look straight ahead as possible at that bird so that my face is comfortable and pointing straight at him. I'm not looking out of the corner of my eyes and looking straight. And then bring your binoculars up, okay? Then it's usually going to be in the field of view. Can't do that with totality because you definitely don't want to look through binoculars at the sun without special filters. And once you get the special filters, then the only thing you're going to see is the sun. So what you do in that case is you close your eyes, put your face toward the sun, feel it on your face, feel it warm on your face. When you feel it the warmest on your face, you know you're facing pretty much toward the sun. Then bring the binoculars up and then open your eyes, okay? Always start with it zoomed as low as possible, least amount of zoom first to find it, and then you zoom in to look at it, okay? But the problem is, at high magnification, everything's going to be moving. So again, I strongly recommend that you put your binoculars on a tripod. And when you put them on the tripod, there is one really critical piece you have to have. Okay, so close your eyes, face the sun, and then bring the binocs zoomed out up to your eyes without moving your head. But as I said, it's a pain in the this time. This was it really was nearly overhead. It was early June and in Houston. So if it's a lot more comfortable if you can put your binoculars onto a tripod. Plus, you can share it easier. You get it aligned, and then other people can come up and look at it. You don't have to change the zoom. You don't have to move it for each one. Each person doesn't have to find it. All they have to do is come up and look. And you can put a little step stool so that the littler kids can look through it too. Now, the critical piece that you absolutely have to have, and again, we're not talking a lot of money, is this piece, which is called a binocular tripod adapter, okay? So it's right here in this picture, okay? So virtually every good pair of binoculars has a mounting screw right here, okay? And sometimes it's covered with a cap. So you take your binocular tripod adapter and you screw it into that hole, okay? And then you take the quick release from your tripod, okay? So you take your quick release and you screw that into the tripod adapter. And now you can mount it onto your tripod, okay? Once it's onto your tripod, then it's nice and secure. And as long as the sun isn't too high, your tripod can work pretty well, okay? But as you can imagine, if it's more than 70 or 80 degrees, it's hard for a tripod to go that far up, okay? For most of us, it'll only be 60 degrees, which is still pretty comfortable on a tripod. Does that make sense? Really important. Okay, so this tripod adapter, this is a high quality one. It's like $25 from Pentax, but you can get them as low as $10 on Amazon. But do the Google for binocular tripod adapter, and you have to have a binocs that have that mounting screw. But a lot of them do. For example, this one that I showed you has a mounting screw, and it's just behind a cap. So sometimes you have to unscrew the cap to find the mounting screw. For some people, it's going to be pretty high in the sky. And so for that, you might want to try a binocular projection, okay? In that case, you use the same mounting bracket, okay, with the same tripod, but now you cover up one of the lenses and you let the sun go through one lens and make an image on a piece of paper. Aligning it is a little tricky. You have to make the shadow the smallest. See how the shadow of the binoculars is the very, very smallest it can be. That means it's exactly aligned with the sun. Once it's aligned with the sun, then you can adjust it a little bit to kick that image over into the shade. If there's sunspots, you can see them easily. You notice this is a 4-inch image, but this is from my bigger binoculars. This is the case where the bigger binoculars make a brighter image, and so you can make it larger, okay? So you can use any pair of binoculars will do this, but the bigger they are, the brighter the image will be, and the larger than you can do it. But you have to be very careful that people do not look through the binoculars when it doesn't have a cap on it. So for those, I put the tripod really, really close to the ground so people can't get up under and look through the binoculars. Here's that same smaller binoculars that I just showed you on a tripod that's fairly low. And now, because it's a smaller tripod and it's closer to the ground, the image is a little smaller. Okay, it's a less of a zoom. This is that 8 zoom versus the 20 zoom. Okay, again, you see how the shadow of the tripod is the smallest. That means you're in alignment and you can get that image. And you just use the zoom and the focusing on the binoculars itself to show that image. Absolutely, you can lay on your back on the ground and look for binoculars. In Texas, you have to worry about fire ants. Ideally, a good lawn chair is the best. And in fact, somebody made a really cool lawn chair binocular holder. It was cantilevered and everything, and he could lay in his lawn chair, and he could tip back as far as he wanted, and it would maintain the right orientation. It was awesome. But yeah, lawn chairs are going to be perfect if you're, in the Midwest where it's going to be more high in the sky. If you're in Oregon, even up to where we are in eastern Wyoming, it's going to be low enough that you can use a regular binoculars. And I have had more people say to me that the binoculars on a tripod was the most comfortable, most realistic view they ever had of the eclipse. I really enjoyed it. Now, one way to make it show up better is to take that same binoculars on that same tripod and just wrap some dark cloth around it to give yourself some shade. So now you've made your shadow a little bigger so you can see the image of the sun easier. So you just cover up one of the lenses, let the light go through the other lens. So, as I said, this is my favorite, the binocular tripod adapter, solar filters, and a tripod. Okay, so the total expense is $20 for each one of those, and you get them from Rainbow Symphony, and $10 for the tripod adapter. $50, okay? Really want to encourage you to spend that. It's not a lot of money. That said, for a group, you only need one of the binoculars on a tripod, okay? Because the partial phases are slow. It's over an hour coming in, and it's over an hour going out, okay? So you only need one set of filters, but what you do want is everybody to have a pair of binoculars hanging around their neck, ready to go without filters, for totality. So if you're going to be in totality, you want everybody to have their own binoculars. And for this, even cheap binoculars are good. Get the opera glasses, roof prisms, whatever. It's more important that everybody has their own, because totality is only 2 minutes and you shouldn't have to share. And that's one thing you don't want to have, is people arguing, hey, it's my turn with the binoculars, Everybody should have their own. That's another one of my. They don't have to be fabulous, but they do have to be them, okay? So, the first totality I went to, I was taking pictures with my camera. I was taking pictures with this telescope, and I had my binoculars around my neck, and I forgot to use them because I was just so awestruck when I finally had 15 seconds to look at the sun that I didn't think about putting my binoculars up to my eyeballs, okay? So don't overschedule yourself. Give yourself time to enjoy it, especially if you're a first-timer. Don't spend your entire time behind a camera lens, because your eyes do a better job. Okay, another really, really good one to observe the partial phases is called the sun spotter. It makes a nice big image because it's got a nice big aperture, but it uses mirrors and simple lenses, so it's completely safe. You can have a kid watch over it. You align it by first making, see this stem? You notice it doesn't have a shadow? That means it's pointing straight at the sun. So you put that stem pointing straight at the sun, and then this dot should be close to the center of this ring. And once you get that close, then you're going to have the sun's image show up here. And it has pieces of paper so people can sketch it. You know, you put a piece of paper down there, and it's a good size image. It's 3.5, 4 inches across. Only downside of this is it's not cheap. It's $400. Okay, and this is how big it is. Okay, but it really is very nice. And if you're going to have a group, especially if you're driving, it's wonderful. But because I'm usually flying, I normally do the binoculars on the tripod instead, because I'm going to be taking binoculars anyway. The nice thing about the sun spotter is it works even if it's almost straight overhead, which is very nice. And no broken necks. Now, hydrogen alpha telescope is even more expensive, and I frequently take them along. Although I must admit, lately I haven't been taking them along just because they have a really hard depth of, very little depth of eye relief, and so you have to keep them fairly tightly aligned, and that can be a pain. But you can preview where the prominences are going to be, which is nice. Okay, so this is me teaching a class and showing to scale. Now here are the binocs on the tripod to look directly. Here are the binocs on a short tripod for projection, and here's a sun spotter. And they all work quite well. Okay, so what activities would you do with your group? Well, punching the boards for the pinhole pictures. Do that the night before if you can. Measuring the temperatures. Even if it's cloudy, the temperatures will change. And especially if you're in, Nebraska, where it's going to be close to 100 degrees in August 21st. Have somebody measure the temperature as a function of time. The sun spotter is fun. You can take a camcorder and mount it on a tripod. And this is just an old cheap camcorder, again with a $20 filter. Get the right size. You measure the outer diameter, and then you order the one that has the right diameter to fit on your camera. So you can do it on a camcorder, you can do it on a telephoto lens, you can do it on binoculars. And the nice thing about these is you want them so they don't fall off. They come with a little extra foam tape, so you get a nice snug fit. So you can keep them on for the partial phase, and they're snug. But then when it goes total, you can pop them off. And what's nice about a camcorder like this is you can monitor it on the LCD panel. You can put a pigtail on it, send it to a TV set, and people can watch it happening. The bigger, newer camcorders, have higher resolution, bigger LCD panels, and they have HDMI outputs, and you can again put them into a TV set so people can be monitoring the video feed through your camera. And again, just the right size goes on there. Another fun thing. Okay, let me. Photographing eclipses under the trees. That reading chart I already showed you. Watching the live video feed of NASA TV and and certainly other things you can do. Now, I'll show you this in just a minute. Okay, so when is the next one? If you miss this one, when's the next one? You get a couple of solar eclipses every year, but some may just be partial or be annular. So there's generally only one total every year. There's often 2 or 3 lunar eclipses each year, and there's at least a partial lunar eclipse 2 weeks before or 2 weeks after any total solar eclipse. That's not the inverse, is not the case. If there's a total lunar eclipse, there will not necessarily be a solar eclipse. So the next total in the United States goes through Texas on April 8th, 2024, and here's the path of the 2024 one. So if you live in Carbondale, you get them both, you lucky dogs. So here's the path for 2024. Here's another one, 2045. I hope I'm still alive for that one. Here's 2044. But here's 2033 in March. So there's if you don't mind traveling, and heck, traveling is fun, you can get a good eclipse almost every year. Now, there will be an annular eclipse crossing the United States on October 14th, and that's also going to go through Texas. This one here, this one just below it, is the one that I showed the picture of the annular when I was in New Mexico. But as you can see, there's various times. There's one in 2021, if you'd like to go through northern Canada. Okay, now, photography. It is really, really hard to get a perfect shot. You have to do a range of exposures and put them together afterwards. You need short exposures for the prominences and the chromosphere. Long exposures get the outer corona, but way overexpose the prominences. So you need to take a range of exposures. It's a good thing to practice with the full moon because it also is bright with a black background and has a tendency to be overexposed by most cameras. Now, if you have an idiot camera, I find if you put it on sunrise, sunset mode, then it forces it to be the focus at infinity, which is important. Okay, if you and also it allows you to underexpose a bit. So if all you have is an idiot camera, be sure you tape over the flash, because you absolutely do not want to take a flash picture, because people will really get mad at you. Now, there's one exception to taking the flash picture, and that is if you are kind of in front of a tree and you've got that eclipse over your back shoulder, and you want to have you in the foreground and the eclipse in the background, then sometimes you can use a fill-in flash so that your face is lit and the exposure, and then the eclipse is over your shoulder. Just make sure there's no other photographers anywhere in the neighborhood, or they will get mad. Okay. The other thing is, be sure you have a red light, preferably a red headlamp, because again, you're going to need. I always have to end up looking at my camera to change something, and having a red light, you won't bother anybody. Whereas, turning on a white light, you're going to drive everybody nuts. So, red lights, headlamps are really helpful. Again, solar filter to match your camera. Okay, 300 millimeter or better is a good telephoto. If you have this one, for example, goes from 75 to 300, and you can set it on manual focus. You can set it on what you want to do on infinity. And what I've got this one set up is that it will do automatically 3 in a row, and it will take one underexposed and one overexposed. It's really, really important that you do not overexpose. If you're going to make a mistake, underexpose. Okay? Really, really important to underexpose. If your camera has a RAW setting, save it as JPEG plus RAW, and that way you get the most detail. Okay. The nice thing about these solar filters is they're tight, but they can come off easily. And if they're a little too loose, then you put a little bit more of this foam in there so it gets a snug fit, so it stays on. But then you can pop it off for totality. Okay. Now, let me just show you a couple pictures I just took today. So just as an example, now I was doing the so this one here, this picture was taken with this solar filter here, and it makes a nice orange image. So this is the 300 millimeter. If I had done it at 75, it would be a lot smaller. Okay. Here is a similar one. Let's see if I can find where my favorite one was. Where did my favorite one go? Yeah, there's my favorite one of the white light. So this one is not this solar filter, but it's called a neutral density filter, an ND filter. And that's a glass filter that you buy that screws onto the top, okay, and is much higher quality to take high quality photographs. Okay, this is a 400 neutral density filter. It's almost not enough, but you screw it on for all the partial phases, and then once it gets close to total, then you take it off. Don't look through the viewfinder, but you can take pictures of the diamond ring with it off, totality with it off, diamond ring with it off, and then put it back on. Okay, but don't look through the optical viewfinder when the camera's off. Another fun thing that this one will do, I can plug it into my USB port. I can control this camera from my computer, and you can watch in real time on my laptop what this is seeing. So I can set this up, point it to the sun with the filter on, and have people look at my laptop. And again, they won't be tempted to bump my camera because they can see it on the laptop. And that's something that many good cameras do now. The software came free with the camera, so that's something I recommend a lot. Now, videography, again, you really need to be able to change the exposure, the iris, and to set manual focus to infinity. Otherwise, both video cameras and regular cameras will try to find the right focus, and it'll go in and out and in and out, and sometimes it won't ever even take the picture because it's too busy trying to find focus. So it's really important if you can put your camera on manual focus. Again, focus on the full moon. You can take off the filters just before the diamond rings. But if all you have is a cheap video camera, I would set at least one of them up, and then maybe it's just an iPhone, on go live, so it captures you and the sun, or you and your family, so you can have a video and audio recording of your responses to the eclipse. Really a lot of fun to be able to capture that. Okay, so this is a multiple exposure photograph, but your eyes, it looks very, very similar to this. And that was a beautiful prominence. You recognize the prominences. So this is the Indonesian. And if you can even at some of these higher exposures, you can actually see the moon surface. That's actual the lunar surface from Earthshine. Okay, so always put the filters closest to the sun. Be sure you can turn off the flash. And absolutely, again, I have a rule in my group, no moving within 4 minutes of totality. Wherever you are, that's where you are, because it gets dark in a hurry and it's going to get bright in a hurry. You don't want somebody tripping over your equipment. You don't want anybody hurting each other. So wherever you are there starting 4 minutes before totality. Okay, so here's my website. It's got a lot of cool stuff on it. Here's the NASA site, absolutely wonderful materials. Here's where I get the solar filters for binoculars or cameras, or you can get the high quality photo filters. I'll be sending out an email to you all with some of these links for things that I like. These are, to my mind, the best binoculars, look at the stars. If the star is red on top and blue at the bottom, then it means it's a cheap it's a cheap lens. So there's the sunset mode. Okay. All right. Well, if anybody's interested, you're certainly welcome to use this PowerPoint, and I showed you already where it is. And I will be happy to answer any questions. And if not, I can show you a little home video of some of our, one of the couple of eclipses that I've been to. Any questions? Laughing, that's a good sign. Okay, let me show you, while we're still here then, let me show you a couple of videos that I took that I think you might enjoy. So this was so you see haze. It's because there were some thin clouds coming and going over it. Oh my God! Oh my gosh! Thank you, Jesus! Well, as you can see, we're all pretty excited about it. But one way that you can often, you know, if you don't have a iris control, you can zoom in and zoom out. Sometimes gives you effectively. Now this is the diamond ring coming out. So here are the Bailey's beads at the top.
Look at the Bailey's beads at the top. Oh my God. Oh my God. Oh, here comes Diamond Ring.
So that's when you have to cover up, and you notice how bright it got. So I was doing several cameras at once, which is why it took me a while to uncover at the beginning and cover up at the end. Well,
Cool.
that's one of many fun things that we do. There's some great shots. So oh wait, this one's pretty. This is just audio and stills that other people have done. That's a video.
Look at the rainbow around it. Yeah!
Well, you see, we get excited. All right.
Okay.
Okay, well, any other questions? So the question is, will this presentation be available to look at? Yes, I just showed it to you all, the people who were here earlier. If you go to my website, which is space.rice.edu/eclipse, okay? If you look down here, it has my safe observing page, which you're welcome to look at, and but kind of hidden, you go to eclipse/PDF.
PDF, yep.
I will be sending you that by email. So yeah. And so here's that worksheet. There's that Eclipse Math PDF. Here's the PDF version of the thing I just showed you. Here's the one that has the movies embedded, and here's the one that does not have the movies embedded. So this is 100 megabytes, and this is about 60 megabytes. So there's the two PowerPoints. Now, it doesn't have those last two movies that I showed, but the last two movies that I showed are also in here. And you can look through all of my solar eclipse directories. There's a lot of fantastic. So here's the Rife video. So there's that video that I just showed you is right there from 2016. And then the other one I showed you was from 2010. So anyway, they're all there, and you're welcome to play with them. Any educational use is fine, just no commercial use without checking with me. Okay, so now did anybody join that I didn't get down on my list? Let's
Probably me.
and who is me?
Kim Webb.
Kim Webb, yes. I saw your name, Kimberly, and I figured
Yes.
that.
Yep.
Thank you.
Okay. I've enjoyed this.
Great. All right. Well, it's past time, so I don't want to keep you any longer, but enjoyed having you all here. And if you want the professional development credits, you've got to do the worksheet and send it to me. And you have to observe the eclipse, and then send me a write-up, preferably with pictures. And then I'll send you a certificate for 4 hours of professional development. And if you think you deserve more, then justify it, and I can give you more. Because I don't want you being out of the path of totality. I want you out. I want you out of the classroom, at least with observing what fraction of the eclipse that you can.
Okay.
Okay, great.
All right, thank you.
Nice
Thank you.
meeting you all.
Yes. Thanks so much.
Thanks. It was a great presentation. Thank you.
Great. Glad you enjoyed it.
Thanks, Dr. Pat. You rock.
He does.
And if you think of anything that you think I should have added or anything, I kind of have time crunch, so I can't add too much more. But if you think of anything that should be added or subtracted, let me know for next time.
Okay. All right. Good evening.
Bye.
Bye.
Bye.